Shall we start?
Hello.
Shall we start, sir? Bishwajit sir?
ম্যাম আমার মনে হয় 2 মিনিট একটু ওয়েট করে যান, একটু জয়েন করুক সবাই, তারপর আমরা
ঠিক আছে।
6:05 থেকে স্টার্ট করে দিই, ঠিক আছে? 3 মিনিট আছে। সৌম্য স্যার, যাদব স্যার কি আপনার কাছে পিপিটি শেয়ার করেছেন? হ্যালো সৌম্য স্যার। সৌম্য স্যার আছেন?
ছিলেন, কিন্তু এখন তো মনে হয় নেই।
এখানে দেখাচ্ছেন। সৌম্য স্যার, am I audible?
I think you need to give him a call. এই জয়েন করেছে।
Okay. সৌম্য স্যার, am I audible?
Yes sir, you are.
আচ্ছা, বলছি যে আপনার ইকো হচ্ছে, কোনো একটা ডিভাইসের মাইক্রোফোন অন
বেরিয়ে যাচ্ছে।
হ্যাঁ, বলছি
এবার ঠিক
যাদব
আছে তো?
হ্যাঁ, এবার ঠিক আছে। যাদব স্যার কি আপনার কাছে কোনো পিপিটি শেয়ার করেছে? হ্যাঁ, শোনা যাচ্ছে। বলছি যাদব স্যার কি আপনার কাছে কোনো পিপিটি শেয়ার করেছে?
Am I audible?
হ্যাঁ, আপনি শোনা যাচ্ছে।
Yes, you are audible. But Bishwajit sir is asking যে যাদব স্যার কি কোনো পিপিটি শেয়ার করেছে আপনার সাথে?
হ্যালো
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 হ্যালো, আর উই অডিবল?
আমার কথা শোনা যাচ্ছে? হ্যালো।
হ্যাঁ, কিন্তু আপনি আমাদের কথা শুনতে পাচ্ছেন না। আপনি আমাদের কথা শুনতে পাচ্ছেন না।
হ্যালো হ্যালো। হ্যালো, শোনা যাচ্ছে এবারে?
হ্যাঁ, শোনা যাচ্ছে।
হ্যালো।
আমরা শুনতে পাচ্ছি, আপনি শুনতে পাচ্ছেন? আমরা শুনতে পাচ্ছি, বাট ইউ শুনতে পাচ্ছি না।
হ্যালো, হ্যালো। Am I audible?
Yes, yes, you are audible.
Hello.
হ্যাঁ,
I hope now this time is audible.
yes, you are audible.
Okay, okay. Thank you, thank you.
আচ্ছা, বলছি যাদব স্যার কি আপনার কাছে কোনো পিপিটি শেয়ার
হ্যাঁ
করেছেন?
হ্যাঁ হ্যাঁ হ্যাঁ, আমি যাদব স্যারের পিপিটিটা শেয়ার করব।
ওকে, ওকে, থ্যাংক ইউ স্যার। সো ম্যাম, ইউ মে স্টার্ট।
হুম।
ম্যাম, ইউ মে স্টার্ট। মুনমুন ম্যাম।
কোথা গেল মুনমুন ম্যাম? আছে? Is she there? She's there. কোথা গেল? মুনমুন ম্যাম, you may start. Just a network issues.
Please give me 2 minutes.
Hello ma'am. মুনমুন ম্যাডাম।
Good evening, everyone, and welcome to the fourth day of the 5-day International Faculty Development Program on Research Methodology, jointly organized by SAIARD and VMM. I hope that all the participants are charged up today after the 3 days active and engaging presentations. Today, we are going to focus more on the statistical analysis. And the first lecture is choice of methods and analysis. I am very proud to introduce my colleague at VMM, that is Dr. Shomo Shaha. And I want to put it on record my appreciation for the efforts that he puts in daily related to student issues as well as student welfare. Not only is he actively engaged in the college and department, he is also an active researcher, and we often go to him for help whenever we face any difficulties in our statistical analysis. And he is always ready to help, as you have already witnessed that over the last 3 days. He is a very helpful person and an active researcher, and he is the one who is behind this organizing this seminar on behalf of VMM. So he is the main man behind this seminar, and I actually he is the one who has engaged me. So I cannot say welcome, sir, because this is his seminar. So thank you, sir, for making me a part of it.
Thank you, madam. Thank you, madam.
So we come to a formal introduction. Dr. Shonu Saha is an assistant professor of commerce at Vivekananda Mission Mahavidyalaya, Holdia, Purbo Bednipur. He is also associated with the Department of Commerce, University of Calcutta as a guest faculty. Before that, he was associated with the Postgraduate Department of Commerce, St. Xavier's College, Kolkata, an autonomous institution under University of Calcutta. He earned his PhD from University of Calcutta. He also completed his postgraduate degree in commerce from the same university. In addition to that, he also earned his Master of Business Administration and MPhil in Management degree. He has over 17 years of experience in teaching. He has a large number of research papers to his credit and has presented numerous research papers at various national and international conferences. I hope that all the participants are going to thoroughly enjoy today's session. Over to you, sir.
Thank you, madam, for your nice words. I don't know whether I am actually receive all those comments from you or not, but madam is also a very good colleague of mine in a college. So not wasting time, we already wasted 14 minutes because of the network issues. So we try to explain the basic problem as a researcher, which I also faced. Generally, this many researchers face that if I going to choose a methodology, then which methodology to choose basically. So that is the basic problem we all researchers face at very point of time. The basic thing by which I will start is generally when we, as a researcher, I can say from my point of view, that generally when we go for a research, generally first we look for a methodology and then we'll go for a objective or research questions. That's a general notion I have at the preliminary level of my, but attending so many of research conference and my supervisor and so many of my colleagues, I came to know that this is wrong. Say, I need not select a methodology first and then select the objective. Rather, we should do the first, then first select the research questions, and according to the research questions, I have to select my methodology. So methodology does not supersede the objective. So rather, this is the basic connotation I will start with. This is the basic way of researcher, because sometimes for simplicity we are doing so. So if which method I should use, and then my objective should be like that. But it should be a reverse direction, and which is true enough. So in today's class, analysis part, I don't know whether 1 hour is a very short span. So in brief, I will just go for a choice of methods in social science. So basically, we are dealing with the social science research methodology, and being a student of commerce and finance, we are doing research, and commerce is also a part and parcel of social science. So that's why I take this opportunity to discuss some of the issues in social sciences in choice of methods. So basically what we're going to learn together basically, or share our views in front of you, is basically these are the way I am going to start basically. So generally we know these are the structure of data. So if I just want to collect the data and put in an Excel sheet, so there are different types of data structure what we have for research. Either we have a cross-sectional data that generally used in social sciences. In maximum cases that we are, whatever the data we used in social science, majority of the cases are the data is called the cross-sectional data. Now cross-sectional data usually collected by observing many subjects like individual, country, farm, region, but the point of time is same. So this is the cross-sectional data, and we all are more or less having a research experience. So we all know about cross-sectional data, and we all, the social science researcher is basically focusing on majorly on the cross-sectional data. And we have different softwares like SPSS is basically deal with this cross-sectional data. SPSS is not that much good in analyzing the time series data, and if we go to the panel data as such. Now, if we move to from cross-sectional data to time series data, now time series data, as we all know, that if a particular variable is recorded over time, so the time sequence should be uniform. So if I record the data for a month, then each month I have to record. If the data recorded for a particular day wise, then I have to record it on a day basis. So if a particular variable is collected, if a particular data is collected over a span of time, the time frequency will be same, then this data is called a time series data. Now this is the day of panel data analysis. We are not in a cross-sectional data. We are not confined ourselves in the time series data analysis, but in a social science research, we more now focusing on the panel data, which is nothing but a combination of, in simple words, I'm not going to very detail of analysis of panel data. What does it mean or simple? So simple way, we can say that it's a combination of cross-sectional and time series data. So different variable, cross section, if we record that data, if we collect the data over a span of time, this simply called the panel data. So we have a basic structure of data, and we have to arrange the data according to the structure of our data. So either the data may be a cross sectional, or the data on which we are going to research on is a time series data, or it may be a panel data. But today what we are going to do, it's basically the cross-sectional data. That what statistical tool or method generally we are going to choose for a cross-sectional data as such. And if time permits, I'll generally come across that how to interpret the results basically. But time is so short. I hope I already spent 20 minutes because of something. I have to end by 7 or maximum 7:10. That is the time limit I have, because the next is Professor J.K. Das, who is also my sir in University of Calcutta. So generally I have to give space for him, because he is my sir and he will give you more input on statistics. Generally, as we already mentioned, that we have to go for a cross-sectional data analysis. I have to go for a choice of method. Now, generally, when you go for a cross-sectional analysis, either I can collect the data from a secondary source, or I can collect the data from a primary source. But generally, if I ignore the secondary part, then secondary data, reliable data, which is already recorded, tested. So secondary data, if I going to analyze my if I going to collect my data for my research from the secondary source, that is called the secondary data, there is no need for a reliability test. The data is already been reliable. But if I have a questionnaire, if I made a structured questionnaire, and generally it has been said that you use a random sampling, it may be a different types of random sampling or probabilistic sampling, then definitely through a structured questionnaire, if I collect the data, then it requires a reliability test. So without a reliability test, I cannot step further for my research. So this is the first step for every researcher to follow, that what is the reliability test value. If your reliability of the questionnaire, if the reliability of the question set is not at all good, then definitely you have to revisit the questionnaire, and you have to redo the sample collection process. But reliability test must be done at the first test. Now, once your reliability test is good, then the next step is called the test of normality. Then generally, as yesterday also in Sir's class, when we learning the regression analysis, generally sir told that there are two types of tests in inferential statistics. Generally, either we can go for parametric test or non-parametric test. So which type of test if I want to apply in my research, generally that needs a test of normality of individual variable upon which we are going to research. So the next step after reliability test is to test of normality. You have to check for each variable whatever you collected through your structured questionnaire whether they are normal or not. So once you find that this is normal and this is not normal, then you can select that which type of test, whether you go for a parametric test or whether you go for a non-parametric test. The broad classification wise you can identify that. The initials, generally, if I just classify the statistics, generally we classify the statistics into two types. One is called the descriptive test, the tools, another is called the inferential statistics. So in any research paper will start with the descriptive statistics, basically like the central tendency and dispersion, and going for a higher order moments like skewness, kurtosis, etc. So generally, any research paper, the next step we have to define the descriptive statistic. We have to go for a descriptive statistics. Now the general question of descriptive statistics is, we have if I go for a central tendency, then we have three different averages. One is called the simple average, another one is called the positional average, that's a mode and median. So we have to find out for my research which descriptive test or which central tendency, whether it's a mean is appropriate, whether it's a mode is appropriate, or whether it's a median is appropriate for my study. That is very much important. And this is the inferential statistics part. After the descriptive statistic part, generally we have to go for a hypothesis testing, and normally in different social science research we have to create a hypothesis based on our research questions or objective of our study. And then how I can test my hypothesis, either I have to opt for a parametric test or I have to go for a non-parametric test. And I already mentioned, to check whether to apply parametric and non-parametric, the test of normality is mandatory, without which you cannot fix that how you can go for a parametric test or whether you can go for a non-parametric test for a hypothesis testing. Now, just the basic idea of reliability test. So generally the notation of reliability test, we measure with the Cronbach alpha. Why we have to go for a reliability test? It's basically to assess the internal consistency of a questionnaire or survey that is made up for multiple Likert type scales and items. Generally in a social science research, when we ask different respondents on a particular issue, generally we prefer to use a scale. Either it may be a ratio scale, interval scale, or a nominal scale, but the scale is basically a Likert type scale, either 5-point or 7-point scale basically. So that's why we are going to collect the information through a Likert type scale, and we need to find out whether there is a relationship between each respondent's answer. So to check the internal consistency or simply high correlation between. So when you have been asked a question and there is another question which may be related to the previous question, the answer should be more or less same in that particular field. So whenever it's a human psychology, then generally we must not deviate from one question to another question. So the consistency of the question is very high, means the correlation value of, if I run a correlation amongst the variables whatever we collected through a Likert type scale, the correlation value amongst variable is high. And if this is so, this leads to the high internal consistency of our data, and it leads to high alpha value. That's a Cronbach alpha value. And generally the thumb rule is, if the Cronbach alpha value of your questionnaire to check the internal consistency of the data you collected through a structured questionnaire is more than 0.7, you are supposed to start your research with this filled up questionnaire, or the respondents answer correctly. Because you know, also this is the real-time problem when you put a questionnaire. Now in our time, we don't have Google Docs. When you start research, generally we have to go door to door and ask the people and collect the data. Generally this is the scenario. But now the Google Doc is there, and how much we truly give proper time or quality time to fill a questionnaire. Now in the virtual world, we receive minimum 5 to 6 questionnaire every day from parts of India, everywhere. And we how many we filled, and then if I filled a questionnaire, whether I am honest to fill that questionnaire or not, whether I'm putting tick in a random way, or we are putting tick after reading, understanding, and giving my true and honest opinion for that result. I don't know how much of we are giving, but my experience is we are not spending that much of time in giving the questionnaire, which needs at least 15 minutes time. We completed it by 5 minutes. So definitely, if this is so, then the problem is with the internal consistency. So that's why you have to check for the data, that whether the data you collected through a questionnaire, a structured questionnaire, whether its reliability is there or not. If it's reliable, definitely you can proceed further. The next step is a normality test. So generally, why we can go for a normality test? Now here the answer is, for a hypothesis testing, you have to choose different methods of testing, either parametric or non-parametric. If you find the distribution is normal of a data set or for a variable which you collected through your questionnaire, you can go for a parametric test. This is also for a secondary data set also. For a secondary data also, you should have to test for normality. If the data is normal, or if the variable is normally distributed, you can choose a parametric test. And if the variable is not normally distributed, then you can choose a non-parametric test. Am I audible? I can see the screen. That's why. Yes. Okay. Sometimes I will, because the net connection and all that thing. So sometimes I will. Okay. Thank you. Then we'll move to the what type of test available with us to check the normality. If I go to SPSS, because SPSS is a very vast usage software in social science research, and we all use SPSS. So if I go to SPSS, these are the two tests generally is there to test the normality of a particular variable. The first one is the Shapiro-Wilk test, and the second one is Kolmogorov and Smirnov test. For a generally, the next test is called the Jagberer test. For a time series analysis, the Jagberer test is is useful to test the normality of the data. But if I use the if I go for a cross-sectional data and use a SPSS software to go for an analysis, then these are the two tests. The first one, Shapiro-Wilk test, and Kolmogorov-Smirnov test is available with us, by which we can test the normality. And how the basic null hypothesis of these two tests are: the data set is normal, and if you reject the data set is not normal. The null hypothesis of these two tests is data set or the variable is not normally distributed, and if you reject the hypothesis null at say 5% level of significance, if you get p-value at less than 0.05, then you reject the null hypothesis, and generally you can select, you can say that the distribution of the particular variable or data is normal. So here I just put in front of you the test values. This is the first one is a Kolmogorov-Smirnov test. So here the p-value is less than 0.05 at 5% level of significance. We can say the variable which I selected for this study is normal. For Shapiro-Wilk test also, it's giving us a significant result. We can reject the null hypothesis and we can say that the distribution is normal. Generally, it has been told that sometimes we find that Kolmogorov test is failed to reject the null, but while Shapiro and Wilk test will reject the null and go for a normality. So it has been observed in research papers, it has been told that Shapiro-Wilk test is better normality test than Kolmogorov and Smirnov test. Move to the next part of the most crucial thing of the descriptive data statistics. And for descriptive statistics, before starting the descriptive statistics in SPSS generally, or in any software, generally the software reads the data into these three scales. Either it can be a scale variable or it can be a categorical variable. Categorical variable are of two types, more or less we all know about it. Nominal variable and ordinal variable basically. So nominal, it may be a string variable. So the example may be the patient, sex, counselor. The ordinal variable which follows a order. So generally, what is the scores, particular who he's a first boy or a second boy or a third boy in a class, or if I just collect the data in a Likert scale, then generally this data is called the ordinal type of data. And scale, basically we have two different type of scale in research. Generally one is the interval scale and generally a ratio scale. Here the two examples are there. Just temperature we can measure in an interval scale. IQ of an individual we measure in an interval scale, and if I go for a ratio, then weight, height of a particular individual are measured in the ratio scale. So generally softwares take the data, and if it's SPSS is concerned, SPSS can only take these three different type of variables. Either it should be a scale variable, it should be a nominal variable, or it can be a ordinal variable. There is no other option by which you can put the data into SPSS to run your analysis basically. Another two terminology generally we use, one is called a string, another one is called a metric. So metric data is a numeric data and non-metric data is called a string variable or a string data. Now this is the important part. Now as we classify the data into two different parts, one is a categorical data, another one is a interval data or a ratio data, that means a scale data, that when should we use what type of descriptive statistics. If your data is a categorical data, you should go for frequency analysis, or you can represent your data in a cross tabulation. And if it requires for a descriptive statistics like mean, median, mode, then after putting it to a cross tabulation you can go for it. But generally say sex, male or female, I can know what is the percentage of male in my question and what is the percentage of female are there responded in my question, but we generally do not find a mean or standard deviation of male and female data. So for categorical data we are more often inclined to present the data in a frequency or cross tabulation format. But if it comes to the interval or ratio data, that is a scale data, or you can say it's a continuous data, then generally there requires a thorough descriptive statistic analysis through the measures of central tendency like mean, median, mode. You can extend it to the measures of dispersion like standard deviation and variance, and the higher order moments like skewness and kurtosis, to know or to describe the data, or to what is your data is all about. So you have to describe your data, whatever the data you collected, you want to understand your data structure, that's why you have to go to describe your data. That's why it's a descriptive statistics. So simple way, if it's categorical data, we go for frequency and cross tabulation, and if it's an interval or ratio data, we can go for central tendency, dispersion, and higher order moments like skewness and kurtosis. Now the few basic important questions. So when should I refer to the mean or median? That's a basic question. So generally the answer is something like this. If the distribution of that variable is normal, you should go for a mean. If it's skewed, you go for median. Now the question is, when should you use mode? But in research, social science research, generally we use mode very frequent, seldom generally. But I can cite you two examples where mode is a very important factor, and instead of mean and median, you should go for a mode. The mode might be useful for a shoe manufacturer who wanted to know the most common shoe size of the population. So based on that, he will make that, if I find that maximum number of size, say a shoe manufacturer is making different types of shoes, different types of shoes basically. So therefore, in different types, generally he is making from 1 to 10 different size shoes. Now if I know from my analysis or from my research that 7 and 8 number is maximum used by the individual who are actually purchasing my product, so instead of producing all those number, I should focus more on these two numbers, 8 and 7. So that's why mode is important in this case. In the second example also, you can cite that if you are a financial analyst and of an e-commerce company, you have been assigned a task to determine the most frequently purchased category of a product in the last month. So based on that, so mode is a value of a variable which occurs maximum number of times. So most frequently purchased category of a product in last month, that basically leads to a mode calculation. So there is in number of example we can cite where mode is necessary, but generally in social science research we seldom use mode. But if my objective, my question required this, then definitely I should select my methodology as mode to analyze my descriptive statistic instead of mean and median. But generally we use mean in a normal distribution. If it's median, if it's a skewed distribution, we generally prefer to use median to analyze the data set, whatever we collected through a questionnaire. So the next step is a parametric test. So for a hypothesis testing, as you already know, we have to choose a parametric test if the data or the variable is normally distributed. Now in t-test, we know that there are three different types of t-test are there: one sample t-test, independent sample t-test, and paired sample t-test. And generally next step we have the ANOVA, analysis of variance. And in analysis of variance we have three different type of ANOVA test. It's called one-way ANOVA, two-way ANOVA, and MANOVA, multivariate ANOVA. So we need to know that when to use this, when to use t-test, when to use ANOVA for my research, when to use correlation analysis, and when to use regression analysis. So I already told about the regression analysis. So today I am not focusing more on the regression part, but I am focusing more on the other part which is not covered till date. So one sample t-test. So generally the one sample t-test hypothesis is look like this. Your H0 will be mu equals to x. That is the sample mean equals to the population mean. So here you want to compare your population mean with your sample mean. So basically it's a inferential statistics, and in inferential statistics what we do, we try to analyze the sample, and by analyzing a sample we try to infer about the population. So if the sample mean is equivalent to the population mean, we can simply say that the sample is a true representation of the population. So in one sample t-test, we simply just relating the population mean with the sample mean. Here the variable, whatever we are taking for analysis, must be continuous and numeric. So continuous means it should be a scale variable, either measured in terms of ratio or interval scale. So data should be continuous and it should be numeric, or you can be say it's a metric data. Now I can cite a simple example for one sample t-test. The mean height of adult ages 20 and older is about 66.5 inches, 69.3 inches for males, and 63.8 inches for females. Let's test if the mean height of our sample data is significantly different than 66.5 inches using one sample t-test. So where you want to test the population mean of 66.5 to compare your collected data whether the sample data mean is equivalent to your population mean or not. You are going for a test that is called a one sample t-test. So if I just formally go for what will be our null hypothesis over here, so 66.5 equals to mu height, the mean height of the sample is equals to 66.5, and the mean height of the sample is not equals to 66.5. So these are my null and against the alternative hypothesis. So generally, if I test it, generally if my null hypothesis is rejected, generally in every hypothesis testing, it is from t-test to ANOVA to regression, we generally do it for do our analysis through a p-value. That's a probability value. The simple way to understand the probability value is what is the probability to accept the null hypothesis. So probability value means, in simple words, what is the probability to accept the null hypothesis. So more it's the chance of accepting it, the value will be near to 1, and more if rejecting it, so value will be near to 0. So that's why at 5% level of significance, if the p-value is less than 0.05, we usually reject the null hypothesis. So based on the result, based on the p-value, we generally either accept or reject the null hypothesis of our study. So this is all about the one sample t-test you are generally used. Now go for an independent t-test. So independent sample t-test compares the means of two independent groups. So you collected two independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. Means in for independent t-test, the two sample you are drawing from two different population. So if sample mean differs, you infer the populations are different. So that is the simple way of understanding the independent t-test. So it's a parametric test. Here we use two different variables. One should be a dependent variable or test variable, and another should be an independent variable. Generally, it is a grouping variable, or we can say it's a categorical variable. Dependent variable, whatever we select for our independent test, t-test, it should be always continuous, either measure in interval or ratio scale. An independent variable should always be a categorical in nature with two or more groups under which, say if I weigh sex or gender is a category, then male and female is a group 2. If income level, say we can classify the income level, we can collect the data of income in different categorical data wise. So therefore we can classify into more than two groups of income level. So the basic thing to run the analysis in SPSS, you have to you have to recall that your dependent variable should always be continuous and your independent variable should always be a categorical variable. Now to cite an example of independent t-test, the simple null hypothesis, the two populations means are equal, against the alternative hypothesis, two population means are not equal. Generally here we assume two things, either equal variances assumed of the two populations or equal variances are not assumed. So generally when we run in a software, generally software from your data set, we will do that analysis. They will give you two rows of data set. One is for equal variances assumed t statistics and p value. Another is for not equal variances assume t statistic and p value. Now whether your data set follows a equal variance or it doesn't fail to assume the equal variance, there is one test is there also which can also help you to analyze which row result you will take, whether you will take equal variances row result or not equal variances row result. So this is basically studied in a SPSS workshop, but this 1 hour time is not so important. It's a paucity of time to discuss everything. I can give you one example for an independent t-test. Generally, if I'm taking a sample data set, students reported their typical time to run a mile and whether or not they were an athlete. Suppose we want to know if the average time of run a mile is different for athletes versus non-athletes. This involves testing whether the sample means for mile time among athletes and non-athletes in your sample are statistically different. So for this, you have to run a independent t-test. So athlete and non-athlete, they belongs to two different groups, two different population. We try to measure this. So that's why we are going for an independent t-test. Here we can set the hypothesis that the difference of means is equals to 0, means athlete and non-athlete, they are taking same time to run a mile, and the difference of mean is not equal to 0, means they are taking different time to run a mile. And here also we can accept and reject our hypothesis based on p-value. Repeat once more, if the p-value is less than 0.05 at 5% level of significance, we generally accept, sorry, we generally reject the null hypothesis, and if p-value is greater than 0.05, we generally accept our null hypothesis. Moving to the paired sample t-test, generally it compares two means that are from the same individual object or related units, or we can simply say that the two samples drawn from a same population. It may be a pre-test or post-test with an intervention administered between the two times point. It is used in medical sciences. So before giving a particular medication and after giving a particular medication. So same group, before and after, we generally go for a paired sample t-test, and we are saying that a population is drawn from a particular individual single population, and we try to test whether this difference between two samples are significant or not. So I'm not going very much detail on it. Here we have to mention that here also the dependent variable is there. Here two dependent variables should be there instead of independent and dependent variable. Here the two variable is dependent to each other. So that's why for paired sample t-test, we are taking two variables which are called dependent variable. But one dependent variable, which is a test variable, must be continuous and measure at two different times to related condition of units. And the dependent variable, the next dependent variable, which is selected for our paired sample t-test, is also a continuous variable. So here we are choosing two variables which must be continuous in nature, and then we can go for a paired sample t-test. Here also you have to assume that the two variables should be normally distributed. Null hypothesis is look like this. Against its alternative, the paired population means are equal and the paired population means are not equal, and we have to test for a null and alternative, and we have to analyze accordingly. So here the variable we have selected a continuous and numeric. So this may be a simple example we can cite on. The sample data set has placement test score out of 100 points for 4 subject areas, say English, reading, math and writing. Suppose we particularly interested in English and math sections and want to determine whether English or math had higher test score on average. Now to test this, we have to go for a paired t-test because single individual is giving English test as well as that individual is also giving the math test. So this particular individual belong to a same population, and we try to compare the means of two different examination score and try to identify whether a particular score is higher than other or not. The hypothesis can be set according to this questionnaire, whatever we are having. So there is no significant average difference between English and math score, against the alternative hypothesis that there is significant average difference between English and math score. And we have to check the analysis through SPSS software by the p-value, and we already mentioned how to select or reject the null hypothesis against the alternative hypothesis with the help of the p-values. So we can go for next the one-way ANOVA. Now till now whatever we are doing, generally what we are doing, we're doing with the two variables. So if the number of variables for your study is increased from 2 to 3 or more, then we cannot confine ourselves or to test our analysis through the t-test. Generally, when the number of variables is more than 2, generally we have to go for ANOVA. Now in one-way ANOVA, generally we measure the means of 2 or more independent groups. in order to determine whether there is statistical evidence that the associated population means are significantly different. So this we analyzed for true groups in t-test, but when the number of groups are independent and it's more than 2, then generally we move to the one-way ANOVA. So it's a parametric test. Here generally we are using two variables. One is called dependent variable and another is called independent variable. Dependent variable, that you should keep in mind that dependent variable should be continuous and independent variable always be categorical in nature. And when you test for normality, you have to check for individual category of that independent variable should comes normal, unless you cannot test this. I'm not going for a more detail on ANOVA. I hope all we know about ANOVA, but the simple thing is ANOVA is that we are going to analyze more compare of means where the number of variables is more than 2. Two-way ANOVA, generally the two-way ANOVA compares the mean difference between groups that have split on two different variables called factors. So generally, in short, if I just cite the example, that you could use the two-way ANOVA to understand whether there is an interaction between, say, gender and educational level on text anxiety. Now we can say gender has impact on text anxiety. We can say individually educational level have an impact on text anxiety. But if I want to find the interaction of gender and educational level together on text anxiety, then instead of going for a one-way ANOVA, we have to go for a two-way ANOVA test. So individually, gender and anxiety, one-way ANOVA, educational level and text anxiety relationship compare of means is one-way ANOVA. But if I want to know the interaction of two independent variable on a dependent variable together, how gender and educational level impact the text anxiety among university students, we have to switch from one-way ANOVA to two-way ANOVA. This is the simple way. So what exactly we are seeing that your research questions is enable you to select your analysis. I'm skipping this part also. So generally these assumptions you have to take: the dependent variable for two-way ANOVA must be continuous, and the two independent variables what you are choosing, that two or more categorical or independent groups. So independent variable whatever you are choosing, they should be categorical, and number of categories they are having must be two or more. And this also, which you measured in terms of one-way ANOVA, the dependent variable should be approximately normally distributed for each combination of the groups of the two independent variable. That we have to test. So if generally when you learn SPSS, generally you need to learn that how to perform this in SPSS also. And the next tips is that homogeneity of variance for each combination of the groups of two independent variables has to be assumed. If the variance is heterogeneous, variance is not equal for two groups, generally we cannot run the ANOVA. I'm skipping the example. Then we move to the correlation test. Generally, when we go for a correlation test, as we learned yesterday, that if I want to find the association between two variables for our study, then generally we go for a correlation test and we measure the Pearson's correlation test. Is a parametric test, and we generally measure the Pearson correlation test to find the association, or we simply say the linear association between two variables. Now this is the pre-test, or this is the mandatory test if I want to find the dependency and independency test, which is actually a regression. So if I want to find out the relationship amongst two variable, then correlation test is a pre-test. If there is no correlation between two variable, we generally do not run regression. So correlation is the pre-test of the regression. If there is an association between two variables, then definitely we can go for correlation test. Now, generally correlation doesn't tells us not more than the association. So it just tells us the association. It fails to tells us whether there is any causal relationship between two groups or two variables, whatever we selected for our study. So that's why if I want to study a correlation, that basically doesn't make any sense only to run a correlation for a research. But if your research question, if you want to find out the relationship amongst the variables selected for your study, amongst the variable for selected for your study, and you want to run a regression, you choose regression. For that you have to run a correlation. Unless otherwise, generally only put the correlation values doesn't make any sense in the research questions. So I'm not going more detail into it. So generally that bivariate Pearson correlation cannot address the non-linear relationship. So if it's a non-linear relationship, we have different correlation like canonical correlation is there. We are going for this also. But we also have the non-parametric correlation test. That's a Spearman sign rank test. Sorry, Spearman's rank correlation is also going for a correlation test, which is a non-parametric one. But in general, the parametric test, if I just go for a correlation test, that's a Pearson's R correlation test. Here, the two variable must be of interval or ratio level, and the two variables should be normally distributed. Then only we can run the correlation. Generally, the hypothesis test for the correlation test look like this. The population correlation coefficient is 0, means there is no association. Against that, there is association. We can test it for two tail, we can test it for one tail, and if it's one tail, it's look like this. So population correlation coefficient is 0, there is no association. And for one tail test, the alternative hypothesis look like this: the population correlation coefficient is greater than 0. A positive correlation could exist, or it may be less than 0, or negative correlation could be exists. As we all know, correlation coefficient lies between -1 to +1. So generally, for interpretation part, this is the thumb rule, or generally the Cohen in 1988 in his statistical paper generally gives this explanation that how to read the correlation. So generally, if it's a mode value, if it's mode R, so as correlation lies into negative number or positive, so mode R, if it's 0.5 and above, generally we say that strong correlation. If it's in between 0.3 to 0.5, we generally say it's a moderate correlation. And if it's between the correlation of your variable lies between 0.1 to 0.3, generally we say it's a weak correlation between two variables. I'm not going to the regression analysis in detail. We already did the multiple regression and generally multiple regression, as well as the optimum least square regression in yesterday's class. So I'm just skipping this part, moving to the non-parametric test. So regression is a parametric test. So regression we detailedly analyze in the last class. So we are moving to the non-parametric test. And in non-parametric test, if the variable we selected is not normally distributed, then we cannot apply T, ANOVA, regression, correlation, anything. Then we have to choose some test which is basically called a non-parametric test. And here the names of the non-parametric tests are there. So chi-square is basically a non-parametric test. Now in chi-square, generally either we try to find the association between two variables, and or to test the goodness of fit, generally we measure the chi-square test. Generally, the other test which is there available in a non-parametric test, the non-parametric test is a two independent sample. Now just listen minutely that this two independent sample test is a replica, or if I cannot apply the t-test, independent t-test, Then if my research question is safe but the data are not normal, then we have to switch to non-parametric. And in non-parametric, instead of using independent t-test, we are going to use the non-parametric two independent sample t-test, which is called Mann-Whitney test. Now the next, if the independent variable is more than 2, 3 or more, now this is the ANOVA. So if I cannot apply ANOVA because my variables are not normal, then generally I have to go for a non-parametric test, and I have to apply a Kruskal-Wallis test to test my hypothesis. So this is the replica in non-parametric from the ANOVA point of view. So ANOVA, the non-parametric part is Kruskal-Wallis test. Now this is for a paired sample t-test. So Wilkinson sign rank test is used as a non-parametric test. So if you cannot apply paired sample t-test as your variable is not normally distributed, then you should have to apply a non-parametric test to related sample, that is called paired sample t-test, that is simply named as Wilkinson signed rank test. And if I go for a correlation test, generally we have a Spearman rank correlation coefficient test, where also we have a Kendall's correlation test, where we can generally go for a correlation test which is non-parametric one. And again, this is the exhaustive multivariate analysis. So in multivariate analysis from multivariate regression, other than that, these four, basically the discriminant, factor, cluster and conjoint, basically are the multivariate analysis for grouping variables. To group variables, generally we use these four different type of multivariate analysis, either discriminant or factor or cluster or conjoint. Now discriminant analysis is very simple. If I want to classify my total sample into two groups, so I can say something like that, who will in a bank loan case, if I say if a bank loan case, from previous example we find a set of customer who are defaulted and someone who are not defaulted. So based on that we can create a discriminant function or discriminant equation, and based on that if I create with the past information and past variable, that what are the variables are important to select, that who is going to be defaulted and who is not going to be defaulted for repayment of loan purposes, I can segregate, I can create a discriminant equation, and by that simply I can group two groups based on who will be defaulted and will not. What is the use of that? If a new customer come to me for a loan, I simply take a particular information presented in the equation from the new customer, put the values into that equation and get a score, that is called a z-score value generally, and I have to relate that z-score value with the previous group. So if the z-score value falls to the defaulted group, I may expect that this new person who asks for the loan, he will be defaulted, and vice versa. So that's why discriminant analysis is very important in research cases in different type of, say you can say that who will pass and who will fail. If you can create that variable list, the independent variable list, that what independent variables will impact the results of a particular individual, then generally you can run a discriminant analysis too. So it is widely used tool in the research field. The factor analysis, generally the factor means it's a reduction of variable. So generally when we prepare a questionnaire, a structured questionnaire, generally we'll go for say 16 to 18 or 20, maybe 40 variables. Now I can work with 40 variables. So I have to club them into groups, into factors, because 40 variables I cannot run a regression. I want to reduce them, combine them in an individual group called factor. So based on that, I just after factor analysis, so it's called the reduction of variable. So I will reduction the variable to a factor, and then now my number of variables will reduce from 20 or 40 to 5 or 6 or 4, then it's easy for me to handle 4 variables to run a regression or to run any other test. So that's why if I want to reduce the variable for my analysis, we generally go for a factor analysis. We have 2 different types of factor analysis. One is a explanatory factor analysis, another one is a confirmatory factor analysis. Generally in research workshop, one 5 days program has been arranged for a confirmatory factor analysis. One 5-day program has been arranged for a explanatory factor analysis. So it is not possible for me to discuss everything in detail in 1 hour time. Next, we have a cluster analysis. This is also one type of grouping basically. So similar type of related people clubbed into one group, one cluster. So this is also a cluster analysis. And generally in market research analysis, the widely used technique is a conjoint analysis. Now we can say in a conjoint analysis, it's basically a survey based on a statistical technique used in market research that helps to determine how people value different attributes, say like feature, function, benefits that make up an individual product or service. So that's why you are clubbing, conjoint. Those who are giving a particular result, they will be clubbed to a particular group. So that's why I'm saying this 4 multivariate analysis is basically a grouping one. Now, how you want to group your total data set, total respondents, to get a homogeneity, because in our commerce or market research in marketing field, that if the what I can say, if the marketer cannot find a homogeneous group, he cannot create a strategy. So to find a homogeneity amongst the wide variety or heterogeneous group, these grouping variables are very much, this grouping analysis is very much required. So with this, I am ending my presentation. What I will share with you another thing is basically I already made this one, a simple flow chart which you can use for select the common statistical test. So this I am not already I discuss in thorough whatever the time allotted to me with this. So this is the thing which I am going to share it with you. I hope this flow chart will help you to identify which type of research question will lead to what type of method, selection of method in cross-sectional data analysis. So thank you for patient hearing. If you have any question, please. Thank you all.
Thank you, sir, for an enriching presentation. And it was actually very relevant because we often know that how to use the method, but when to use which method, that is very important. And you have focused very nicely on that. And I hope that our participants have also equally enjoyed the session. Now, if you have any questions, you can go forth, please.
Excuse me, sir. Sorry for the
Yes,
interruption.
please.
Sir, in the STS package, we can take P less than 0.05. It is reject H naught. Otherwise, you can take accept H naught. So why you are not taking the table values, sir? Actual table values is there now.
See, software generally, say when we learn statistics in classroom, generally we don't have an idea of p-value. We always accept or reject or based on the t calculated with the t tabulated value. So definitely you can do this, but when you go for a questionnaire, then it's very difficult to use. Say some point of time SPSS will not provide you the upper limit and lower limit of the critical value for a 5% or 1% level of significance. So generally it has been we can say it's a general thumb rule, or general, it's more that's why instead of critical value, there may be a problem with the critical value sometimes if you take it wrongly or something other. Instead of that, if you just go for a probability, that's why p-value, I told you in simple words that it's a probability of selecting the null hypothesis. So
Yes,
that
sir.
is
It
a
is
more
under.
realistic one to choose a null and alternative, and sometimes software will not provide you the critical values, they will only give you the p-values. Now think of a regression analysis, what you saw in the last class yesterday. Did they provide you the critical value? How
Yes,
you
sir.
calculate? You need not to, you have to calculate manually then.
Yes.
So
So in the
why the waste
manually,
of time? So as we are using software to just to save our time, that software is just saving our time. So that's why not to use p-value instead of going to critical value again, what we did in our classroom.
okay, sir. So in the generally we can take into the non-parametric test, we can take into p less than 0.05, it is a reject H naught, otherwise you can take into the accept H naught. In the parametric test, justly we can take into the table values only, sir. Just and that's why I'm asking you, sir.
Yeah, sir. Because table value you can only calculate it for parametric test because there is a parameter. For a
Yeah.
non-parametric test, there is no parameter. Where can you find the mu? And then plus minus 2 standard deviation. There is no parameter for non-parametric test. That's why it's called non-parametric test. Parameter means say mean, median, these are the parameters, standard deviation. Parametric test has this parameter, that's why it's named as a parametric test. Non-parametric test, we don't have a parameter for that. That's why we cannot calculate the critical values for it.
That's why we
So
can
we
take
don't
only
have
the
to
just
choice
p less.
unless otherwise we have to go
Yeah.
for a p-values.
Sir, one more
I hope
question,
I'm
sir.
making sense. Yeah, sure,
Sir,
sure.
sir, ANOVA two-way analysis, which variables we are taking, sir? Either dependent or independent variables, sir?
For 2A,
Yes, sir. Two-way
sir,
analysis.
say basically it's basically two variables we are taking, both are two independent respect to one dependent. So it's basically two independent and one dependent, and you try to analyze the interaction of two independent variable upon the dependent variable.
Okay, sir. Thank you, sir. Thank you very much.
Thank you, ma'am.
Okay, there is another question from Mrs. Shopna Shah. She asks, how do we export the data from money control to SPSS?
You cannot export directly from money control to SPSS. You have to copy and paste the data into a Excel format. From Excel, you can if I just create the Excel sheet from whatever the data you got from money control, make a Excel sheet of it, then definitely you can import the data into SPSS. But directly you cannot import the data from Excel, from money control to SPSS. One step you have to add. First, you have to copy and paste the data according to your variable wise, format wise in a Excel sheet. Then you can import that Excel sheet to the SPSS. It's SPSS is basically look like a Excel only. So it will, in toto, whatever you put in the Excel sheet, it will come in toto in the SPSS. And then you just run this.
Hello, sir.
Yes, please.
Yes, sir. This myself is Kishore Kumar Das, sir.
Yes,
I
sir.
am from
Tell
Odisha,
me.
sir. Yes.
Yes.
So my question is, sir, is it right to use mixed methods like qualitative and quantitative data calculation and analysis methods to get the answer to the research questions?
Can you repeat your question one time more?
Yes, sir. Is it right to use mixed methods like qualitative and quantitative data collection and analysis methods to get answer to the research questions?
Yes, yes, of course, of course. It's depends. Say you cannot stick to only one type of data. It's my point of view. You cannot stick to only one point of data. If your research question permits quantitative analysis as well as qualitative analysis, definitely you can go for it. Because see, statistics, the software merely gives us certain values. Now, while you have to interpret, the major problem of researchers starts from after accepting and rejecting hypothesis. Next what? That part is your qualitative one. How you interpret that results, how you can apply that results is basically a qualitative one. That That's basically subjective. One researcher interpret a particular data in a particular way. Another researcher will do it in a similar way. So generally, I prefer that combination of both. If it requires to answer a particular research question, both quantitative or qualitative, it's absolutely fine. No harm in it.
Yes. Sir, my second question is how to choose the right methodology for research paper, and what is the significance of Pearson correlation?
What is the significance of Pearson correlation means?
Yes, sir. Yes, yes.
Significance of Pearson correlation means what? Generally, if the correlation coefficient is not significant, it doesn't make any sense.
Yes, yes, yes.
So, say I run a correlation. Say I can give a simple example which I used to give in my class also. In my college there is a very big playground in front of my college, and there is so much of grasses. So, number of students in my college and number of grasses in the field. If I find run a correlation between that, and it gives me a high correlation, say 9. Can I say that number of grasses increases? That means number of students will increase in my college. So it doesn't make any sense. So whenever we have to select a particular methodology, you have to go for a literature. I have to find whether there is a theoretical support in it or not. Then we can go for it. And for correlation analysis, generally, if it's not significant, generally no statistical value. If it's not significant, it doesn't make any sense. So each statistics method, whatever we are going to use, we have to use based on the significance level. If a correlation test result is significant, then it has some meaning. Unless it has no meaning, you can simply ignore that for the analysis. You cannot, you don't have to interpret it. And for the first question, how to select method for research papers. Again, method is for whether it's a PhD thesis or it's a journal paper. Generally, the way I represented, you have to choose based on your research question. But one thing is problem that your paper will be selective if your question and research methods are okay. But generally, again, that the first way I started with, we always select a methodology first, then we go to the research question. Now, based on that literature bibliometric analysis, we can say that what is the prominent, you can analyze that, what is the prominent tool right now is using in research paper. And you can choose the research analysis by that, and then say to your objective. But this is not the methodology, basically, what I assume. I hope I am making sense to your question.
Yes, sir, I got the answer, sir. Thank you, sir.
Okay, thank you.
Okay, that brings us
I
to
hope
the
I am,
end.
yeah, thank you.
That brings us to the end
Please
of
continue.
the first session. Thank you, sir. And please, if you would allow me to present.
Yes.
Good evening, ma'am, and good evening, sir. I just want to say one thing
Sir,
that
sir, I will
Sir,
take your question after the JKD sir's class. So you just go to the, already it's 9:19. I will take your question after the next second session. Please wait for me.
sir, there is no question. Just I want to say that the
Okay, I will answer
recording is
your
not
question at
coming.
the end of the second session. Please bear with me. Let the second session start. You will just write your question. We'll definitely come back to your question.
okay, the next session for today is statistical analysis in social science research by Dr. J.K. Das. I am a direct student of Sir, and I have been very lucky to be a student because the first exposure to statistics has been in Sir's class. And we used to be awestruck by how Sir used to effortlessly solve the problems of statistics. And at the end of every class, we always were like asking for more. And our interest in statistical analysis has grown from there. The thirst or the love for research has been imbibed in us in Sir's class by Sir, and he is one of the stalwarts in the field of statistical analysis. And when it comes to the MCOM department and the MBA department in Calcutta University, like Sir, you can say is the last word when it comes to statistical analysis. So welcome, Sir, to this FDP, and I am sure that our the participants are going to thoroughly enjoy this, and they will also be fully enriched by this session. Welcome, Sir. Now, being a student, I feel very privileged to introduce Sir. Professor J.K. Das is the Professor of Statistics, Department of Commerce, University of Calcutta. He was the HOD, Department of Commerce, Director, University of Calcutta, Calcutta Stock Exchange Center of Excellence in Financial Market, in charge MBA, Financial Management, Director, Internal Quality Assurance Cell, CU. He has been actively involved in teaching statistics, operations research, research methodology, marketing research, and business mathematics at postgraduate level over the last 28 years. He has, to his credit, more than 80 research papers published in national and international journals of repute. Dr. Das has attended and paper presented in more than 150 seminars and conferences and symposia. He has chaired sessions in several national and international seminars and conferences. He has delivered more than 200 invited lectures on various topics. He has been authored several books on business statistics and research methodology. He has supervised a significant number of PhD and MPhil scholars. He has completed a number of consultancy projects and research projects. He is a member of advisory board and member of board of studies of various institutions and universities. He has designed the syllabi and has been associated with the examination process for different central and state institutions. Welcome, sir. Over to you.
Formally welcome, sir. This is Shoumo. Thank you for accepting our invitation and be a part of. Ma'am, if you can stop your presentation, I have to share. Okay, thank you, ma'am. Sir, your microphone is muted. If you can.
I'm sorry. Thank you, Shoumo.
Thank you, sir. Thank you, sir.
From my part, I am very much thankful to Bishwajit, especially Dr. Bishwajit Roy Chaudhary, and he invited me to in this typical faculty development program. So I am very fortunate to say a few words in this program. But as you know, the type of topic I have selected, and it is really a vast topic. But I will not go to any mathematical part of this area. Rather, I want to just make you understand where we are making some problems basically, because when we are selecting the different tools and techniques of statistics, where we are making problems basically. And Somo has nicely, just I was present for a few minutes of Somo's session. He has nicely presented this part which he has selected already. But first of all, let me come to the area. That means why this sort of specifically I am interested in the empirical research part in social science. So why we are interested, that is what is the role of statistics over there and how people are selecting. That means especially if you see this particular screen now, that is more, I'm not going in details of this, more complex operating environment nowadays. That is initially the situations were very simple in nature. Now they are very complex in nature, more complex business or social structure, increased uncertainty everywhere. That means gradually the uncertainty is increasing. I will be coming into the part when I'll be in the subject. changing customer or society's requirements, changing market or society's behavior, social and environmental security, then large error cost, complex information system, reduced reaction time, increased competition. So if you are a researcher, see that the huge amount of pressure, you are under the huge amount of pressure. So what scientific techniques which are available, they will help you to take the decision properly. Because earlier also we used to take the decision without using this sort of scientific technique or the statistical technique, but that time the most of the decision were subjective in nature. That means a same researcher or the similar type of researcher who are taking the data from the different rather from the same area or same time point, but their conclusions were completely different. So accepting getting our degree, this type of analysis, this type of interpretation, this type of conclusion has no other relevance as per my perception. So in the next slide, I have tried to explain. That means you are already in this process, but I do not know exactly that is who are the teachers and exactly what type of sessions they have taken. But just to give you a quick review of this, any research methodology, that means there is a small difference between research methodology and statistics. That's why I'm just coming to this area. Statistics means it is you are driving your car with the trainer. That means when you are sitting in the driver's seat in a new car and your trainer is there, he is having another brake and clutch with him, so that you are feeling that, okay, you are driving your car, but he is really, the other person is really, or the trainer is gradually developing your confidence. But the research methodology is a different thing, where you are driving your car, nobody is there in the car. So that part is, that means when you are coming to the research, so nobody is there to help you. You have to select the topic of your own. So there are 5 broad divisions of this area. The first is the problem formulation, then designing of the research, then data part, then analysis of the data, then finally the report writing. So the entire process, that means these 5 different steps, out of these 5 different steps, only 2 steps are directly statistics. That means maybe that if I consider 100% of this research methodology, the step 1, that is problem formulation, step 2, which is the designing of the research, and step 5, which is the report writing part, they are consisting of only say 20% of the total weight. 80% of the total weight of the empirical research goes to the data collection as well as data analysis part, where from you are getting the findings basically. So in the first part, actually, since most of you are researcher in this area or teacher or something in this discipline, so problem formulation consisting of the problem definition, literature review, research objective, hypothesis formulation. I'm not going in details of this because number of classes you have done, I think, in this area. The second part is actually type of research design. Even when you are considering the research, that is both step 1 and step 2, they are totally they are planning part. This is not the field part of the field basically, because when you are designing a research, or you are taking a particular topic, how to pursue this research, all these are actually planning part, starting from your experimental design, scaling technique, one of the part. I want to just say few words in the scaling technique in the appropriate place. Then questionnaire design, because scaling techniques plays a very crucial role. I was listening to a question, one of the participants was asking a question to Somo. That question was very nice question, that is, in a single research, both qualitative and quantitative, both type of analysis will be required, or both. So that depends on how you are designing the questionnaire. That means your basic instrument is the questionnaire. That's why this scaling technique nowadays is a very crucial type of instrument where we are going to consider. That means that part will demand a lot of new tools and techniques basically. Coming to the third step of this research methodology, that means the sources and data collection part. So in the sources and data collection part, type and sources of data, method of data collection, sampling technique, all these are the different tools and techniques are there. But one of the most important technique is how to decide about the sample size. There are a lot of tools and technique. Sometimes we can have our budget restriction approach, like say my population size is of 1 lakh. How many individuals or how many interview we are going to consider? It depends on the budget, but some sophisticated techniques are there, depending on the confidence interval approach, depending on the Bayesian approach. Lot of sophisticated techniques are also there. So more sophistication you are applying in your research, the result will be more reliable. That is my message basically. And the fourth step, that means where I want to concentrate today itself, the data preparation and data analysis. That means coding, editing, data entry, univariate data analysis, multivariate data analysis, forecasting techniques, and use of statistical packages. Obviously, because earlier people used to take some data and it is a sample data. But nowadays, not necessarily always you are using the sample data. Like say, directly you are getting the data from different type of secondary sources. They are not necessarily the sample data. They are directly the population data. That means number of data points will be relatively large. That's a nowadays there's a new concepts comes like say big data analysis or data science, etc., for which the ordinary type of packages are not enough. You need some new type of packages which type of packages can handle this type of data analysis. And final part is even if you try to write the report, that means in any sort of research, starting from your problem formulation without depending even on your supervisor, starting from your data collection or just problem formulation, if you just reach to the report writing as well as report presentation, that is the overall contribution of this research methodology or market research books. So a scientific report in our childhood days or in our early days, student days, we used to follow say our seniors format. Let us see our seniors who have done what type of report they have done. Based on that, we would have taken what type of report I need to do. But really, you don't need to depend on that type of report. Scientific report which will be having different components. I am not going in details of this, the title page, the preface, the table of content, etc. When you are writing a thesis or dissertation, how to, or even the paper, how to write this in a scientific manner, everything is there in any standard research methodology or marketing research books. So this is all about the research methodology. There is a small difference between research methodology and research methods. Sometimes we are a little bit confused with this terminology. Research methodology is that different type of methodologies, rather starting from your research problem formulation to finally the report writing part. This entire process, entire journey is known as the research methodology. But research methods, some tools and techniques, like say Shaumo, who has explained different type of tools which will be required in the research, they are basically research methods. They are not research methodology. But research methodology is that subject where from you can get starting from your problem formulation to end of report preparation as well as presentation. That is the basic difference between the research methods and research methodology. And similarly, next I am coming to the classification of the research, because though I am not interested in the classification of the research, basically I'll be mainly concentrating on the empirical research, but there could be conceptual versus empirical research, descriptive versus analytical research, applied versus fundamental research, quantitative versus qualitative research, cross-sectional versus longitudinal. Just I want to just take 1 minute on this particular point. Shaumo has nicely presented this cross-sectional part of this. So when it is longitudinal, let us see the difference between cross-sectional and longitudinal. Cross-sectional means the data you are collecting at a particular point of time. Say this is data for a particular year for different factories, different society, different villages, different blocks, etc. But if I do the same thing for several years, that is with respect to time, if you are taking the continuous data, then that will be the longitudinal. That means for long time you are evaluating the same, that will be the longitudinal. So the type of analysis you are using for cross-sectional data, not exactly applicable to the longitudinal data. For longitudinal data, more specifically, the time series analysis will play a very crucial role. So sometimes for different type of research, we take conclusion-oriented research, sometimes decision-oriented research. So in most of the theses, we take the conclusion-oriented research. But if you are in an organization, you have to take the decision why the sales is declining. That is decision. So that you have to, that means what to do next. So that is also one type of research, but ultimately decision-oriented research. And just I have tried to consult number of books in research methodology. If you find not in a single book, you will find all the chapters. But a research methodology book consisting of these are the areas like say introduction, scientific method of research, classification of research, research problem formulation, type of research, hypothesis formulation, literature review, research design, experimental design, research proposal writing, then attitude or measurement scaling techniques, reliability, validity, questionnaire design, sampling technique, sample size decisions, secondary data collection, primary data collection, data preparation for or processing of the data, displaying data. Sometimes only on displaying the data, only on graphical presentation of the data, you can see a lot about the data analysis. Then parametric, non-parametric approaches, univariate data analysis, bivariate data analysis, multivariate data analysis, advanced multivariate data analysis. That is the multivariate data analysis already stated some tools and technique. Beyond that also some more techniques are there. So if the multivariate techniques are clear, then only one can go for the advanced multivariate analysis. Then forecasting techniques, qualitative data analysis, decision theory, research report writing, guidelines for project are given. Because those who are in a teaching profession, you have to guide some students for their projects. So if you consult any research methodology book, there may be that one chapter is dedicated for how to prepare a project work basically. And finally, the ethical issues of research, because that part I'll give some more weight when I'll be using the statistical tools and technique. So number of books, that means if I have tried to consult the number of books where from I get all these chapters, but any single book will not give you all these chapters. So research methodology means whether it is written in 5 chapters or whether it is written in 10 chapters, that's a different story, but these are the basis of the research methodology. Now I am directly coming to the research tool. That means where I am interested. Even if as I have said that I am going to consider only the statistical tools, but only statistics will not make you very clear about the application of this subject. You must have some basic knowledge of mathematics. You must have knowledge of statistics. And I have already explained the difference between the statistics and research methodology. Marketing research, the students or the researchers who are directly coming from the area of business or management or commerce, they can consult any book on marketing research, because marketing research books are more vivid in nature or more case-oriented nature. So you will get more interest in marketing research books. Then obviously in decision-making system, operations research tools and technique will help us a lot. Finally, since huge data we have to handle, so computer applications also. So all together, that means starting from mathematics to computer application, all together we call it the statistical application or the application of the quantitative technique. Now I am just taking this particular diagram. With this context of this diagram, I am trying to explain what is the need of these tools and technique and how these tools and technique will help you a lot through this diagram. Then gradually I will proceed to show you quickly the other thing. Now see that this particular diagram is this is a 3-dimensional figure, and in our the first dimension, that is x-axis, it is not the colloquial axis. I take this first axis as the uncertainty axis. That is things which we are handling everyday life, they are not certain in nature. So uncertainty or probability is something which is involved with the decision making system. You need to know the same. Second one is the variables. Always we are not using only single variable or univariate case. We have number of variables at the same time. So we have to use the multivariate case also. And the third axis is the dynamism. But I'll concentrate on this uncertainty first here itself. That means why should we require this particular subject, the statistical techniques? Why should we require this particular subject? See that if the uncertainty is 0 in the x-axis, then the things are called certain. More you go towards the right hand side, more they will be uncertain in nature. Let me take some example for your simplicity, because I am not going in details of mathematics. The 1 hour class will not be enough to handle all this, but I want to raise some question where from we can make some time for interaction. Actually, in the interaction session, I will be able to say you, or I'll try to give you the answer which are the right technique or appropriate technique to be used in the different places, etc. So uncertainty 0 means certain. That means when you do not have any uncertainty, then we can handle the situation with the help of mathematics. Then the question arises naturally: what's the difference between mathematics and statistics? In the graduation level, we ask in the first year students, that is, what is the basic difference between mathematics and statistics? To me, the basic difference is that when the things are happening with 100%, that means some events are there which you are performing. Like if I perform 2 plus 2, that is an experiment. 2 plus 2. If you add this type of, or if you just perform this type of experiment, number of times you are performing the experiment, they are giving the same result. But in our real life cases, like say same time I am leaving my home, but I have to reach a particular place, the same distance, every day I am reaching at the different time. Or lot of activity you can consider, like say no two humans are equally alike. Though we are having everything, are human being maybe that, but still you will find our body temperatures are not same, our thousands of pathological characters are not same. So the variation is obvious in the system. So how to capture this behavior? Because only on the basis of mathematics we cannot run our system. Rather, mathematics is obsolete in some sense, excepting few fundamental constants. Especially those who are coming from the science background, you will be able to understand. That means, say that the theory of light, say Newton's theory of reflection, theory of refraction, but the diffraction theory was unable to explain this diffraction theory by the Newton's principle of light. So new theory of light comes, Huygens principle. That means mathematics is such, whenever you are performing this type of experiment, you are getting the same result. But statistics is that the results are not uniform in nature. So we are in the situation. Why should we apply this subject? Because we are in the situation where the problems are always of this type. That is, same medicine I am taking and some other person is also taking, but the results are different. Thus, at the same time, you are taking your blood sample, sending to the different path lab, but the results are different. Sometimes it is machine error, sometimes it is other type of error, and so on. I am not going to that part. So more you are entering into the complex system, the more your findings will be more reliable. What I am saying is this: your findings are based on the statistical tools and technique, the findings will be more reliable. So the study of uncertainty axis is nothing but the study of statistics. So broadly, the study of statistics is divided into two groups. One is called the descriptive statistics, other is called inductive statistics. What is descriptive statistics? Some of the chapters, namely say data collection, data presentation, frequency distribution, then central tendency, dispersion, skewness, kurtosis, etc., all of them are known as the descriptive statistics. Now, what is the broad objective of the descriptive statistics? Broad objective of the descriptive statistics is that it will give you some type of satellite vision about the data. It will give you some type of satellite vision or the helicopter view of the data. That means my entire population is of 1 lakh. I have collected only say 500 data points. So based on these 500 data points, whatever the criteria, descriptive statistics means the central tendency feature, the dispersion feature, the skewness feature, the kurtosis feature. These are instead of having this huge number of data, we are coming to only few characters, namely, say, as I have already just mentioned, the central tendency measure, the dispersion measure, the skewness and kurtosis. Based on this, you can say a lot. For example, I'm just trying to identify the small things only. Say, even in the data presentation part, what do you know very clearly where to apply the bar chart, where to apply the pie chart? Even if it is bar chart, where to apply the residual bar, where to apply the vertical bar, where to apply the component bar, where to apply the horizontal bar, where to apply the residual bar, where to apply the divided bar, and so on. That means when you are writing a report, that is very crucial. Grammar wise, you must be correct, otherwise your report will not be accepted by any agency who are scientific in nature. That means whenever you are sending any sort of report for publication in any places or any journal, something like that, they initially try to understand whether you have followed any scientific techniques, tools and techniques or not. So similarly, coming to say even the frequency distribution chapter, what is the difference between the cumulative, the column diagram and the histogram? What is the difference between ogive and step diagram? What is the difference between frequency curve and frequency polygon? And a lot of things are there, because ultimately these things you are going to apply. Even in the central tendency chapter, there are a lot of people always say that, okay, oh, median mode. Can you tell me the proper application of the mean and proper application of the median and proper application of the mode? I am just taking a very simple example from the mean, and more specifically, it is arithmetic mean. Suppose there are two places like A and B. You are moving from A to B with say 20 km/h and coming back with from B to A with 10 km/h. If I ask you a very simple question, what will be the average speed? And in most of the cases, you will be saying that, okay, the speed will be 15 km/h. But unfortunately, this is the wrong answer, because it will be less than 15 km/h. These type of problems are there in our even algebra book in class 5, 6, 7, 8 level. So that's the problem. That means what type of application we are going to consider without knowing their tools and technique, without knowing their presumption, without knowing their regularity condition. When you are applying this subject, the application of the subject will be wrong and corresponding the conclusion will be wrong. Even when I am having the mean, like say two students ask something like that, sir, what is the average score in this particular subject? Suppose one student who have answered 100 out of 100, another student who have answered out of say 3 or 4 marks answer out of 100, then they are asking me the average score, because from average they are trying to know something. I am saying that, okay, the average score is 50. Who will be happy with this average? So sometimes this average has no meaning simply. Here typically what I am saying, the average has no meaning simply. And sometimes the standard deviation also, like if I take say 5, 7 and 10, whatever the standard deviation or whatever the variation you will calculate, the 95, 97 and 100, you will find the same variance or same standard deviation or same variation. Then what is the implication? Because we are saying that based on the measurement we can say a lot, but we could say nothing. But here typically if I say that, okay, the mean is this and corresponding standard deviation is this. So this mean plus minus standard deviation within which you can identify, as I was talking about this satellite vision, mean plus minus standard deviation within which you will be having say almost 70% data. Mean plus minus 2 standard deviation within which you will be having 95% data. Mean plus minus 3 standard deviation, any type of data you collect, you will find approximately mean plus minus 3 standard deviation within which 100% data will be there. So see that only mean and standard deviation you are having, and based on that, whatever may be the number of data points you have collected, it can be 500, it can be 5,000, it can be 5 million, billion, I don't have any problem, but I can identify where from you have collected the data. So that's the beauty of this subject, that's the beauty of the descriptive statistics. And even if I say that most of the people say like this skewness kurtosis, this chapter has no relevance at all, but this is the most important chapter, I would say, because the data behavior, this is a typical behavior of the data. The skewness is nothing but the degree of asymmetry, and kurtosis is nothing but the degree of pickedness or the height of the curve, actually, frequency curve. So these all together, they play a very crucial role. For example, highly positive, the income distribution is positively skewed. What does it mean? That means towards the lower income group, most of the people will belong, and towards the higher income group, less people will belong, and so on. Like say, number of accidents, it follows a Poisson distribution, not that Poisson distribution is highly positively skewed. What does it mean? That means the number of accidents will be less. These number of days will be more, and number of days accidents will be more. These number of cases will be less. For example, in Kolkata, we are running say 30 lakhs car. So if the daily number of accidents is 5, then your insurance premium will be one type. If the daily number of accidents is 50, the premium will be of different. So the insurance companies, they are using this type of data. They are trying to exploit this Poisson distribution, the behavior of the Poisson distribution, and try to develop the model. Accordingly, they are deciding their premium actually. So these are the different contribution of this subject basically. And one more thing in the skewness and kurtosis chapter, most of you are familiar with. In the skewness and kurtosis chapter, there is a concept of moments basically. Moments, what is the role of the moment? When two students, suppose out of 20 marks, two students, they have got the marks like this, 10 and 11. Then approximately we say that, okay, you are of similar type. Now see that if I make the square of the data, 10 square is 100, 11 square is 121. Similarly, if you go on taking the higher power, gradually you will find the differences. So two data sets, when you are comparing, like say t-test, you are applying, the other two group of people you are comparing, two group of choices, two group of social activities you are considering. So whenever two group of people, they are having the similar type of moments, then only we can say that they are identical. Even just we have tried to minimize this concept in that at least the mean is the first order moment, standard deviation is the second order moment, or the variance is the second order moment. If mean and variance are identical, then also we can say a lot about this. That means all the tests which are dependent on this mean and variance as this t-test, etc. So they are considering only these two moments, even on these two moments. So moments are playing here a zoom in case, you can say. Zoom in means higher order moment, zoom out means lower order moment basically. So that's a other part of this subject. Coming to the inductive statistics, in the inductive statistics, you are having the different chapters again, the probability to know the uncertainty behavior. We are having the probability concept. We are having the sampling concept, because how to collect the data, we depend on the different type of sampling, or the sampling concept is some scientific concept without knowing much of statistics, even without knowing much of tools and technique. Even in the data collection phase, you can say a lot about, or you can just save in a sense that your data accuracy, your conclusion accuracy, your data findings accuracy will be much more than that of the other cases if you properly apply the sampling technique even. So sampling technique, then the chapters are chronologically designed in this way. When you are taking any sort of decision based on the sampling, that is the part of the population, what is the role over here? Ultimately, we are going to estimate something. Even for students, if I consider a particular question paper, so that means if the question bank consisting of 500 questions and we set a question of only say 10 questions, so out of 500 questions, 10 questions can be selected by 500 combination, which is an astronomical figure. That means in an astronomical way you can create the questions, but you have tested only through one of them. Have we done correctly? That means the way we are assessing that particular student by using this. So estimation is nothing but the assessment. There are again a lot of techniques in the estimation. Some technique will help you how efficiently we can estimate the same, and some techniques, some desirable tools and techniques are there. They will help you to check the closeness between the parameter and statistics. What is parameter? Parameter is the, like say my entire pathological character. For example, what is my sugar level? That is a parameter. But whatever the value I am getting from the path lab, just based on the say 1 ml of blood, which is a statistic. For a student, what his knowledge or her knowledge is nothing but the parameter, but whatever the marks he has got is the statistic. So the closeness between parameter and statistics. Similarly, in your research area also, whatever the population, it is 1 lakh, 2 lakhs, 5 lakhs, 5 crore, etc. They are the, based on this, whatever the type of calculations you are making, they are the parameters. And whenever you are taking a sample, based on this, whatever the type of calculations you are taking, they are called the statistics. So what is the gap between the parameter and statistics, and what scientific technique will lead you to take the better decisions? That is more important. So here I am coming itself. That means similarly, the next chapter will be the testing of hypothesis. Somo has nicely elaborated the same. Now, what is the need of this testing of hypothesis? Because you are taking all sorts of decisions based on the sample. So there is a possibility that you are making some mistake. Even out of 400 pages in a book, even if you just check 350 pages, there will be a question in your mind that I have not checked these few pages. So there can be some printing mistake in these pages. So whenever you are depending on the sample, there is a lot of other activities are there. So you must keep it in your mind. So testing of hypothesis will make you understand or will help you in the way that the parameter and the statistic, if it is tested and scientifically it is accepted, then only you can say that, okay, this particular sample estimate is the representative one of this parameter. That means the type of medicine, suppose right now the vaccination is going on. So we are claiming that this particular vaccine is can do this and that. But have they studied everything? Not yet it has been studied, because ultimately, if you are not studying this properly, then what type of study they have made is very small sample basically. So whenever you are taking any sort of decision on a small sample, when you are trying to generalize the same, there could be a lot of problems basically. Reason is very simple. Even if I take an example from biology, you'll find that though we are from the same age group, maybe that, or even our different body parts, the sonography or the radiologists, they say that, just I've worked a lot with the even this radiologists also regarding our different measurements of our physiological part. So there also will find lot of differences. So why this lot of difference? Because apparently we see that, okay, two humans are equally alike, but nothing is alike. Under this unequal situation, we are trying to apply this subject, because this subject has the capacity, this subject has the ability to extract the information from this situation. Talking about this analysis of variance and analysis of covariance, sometimes it happens like this. I'm taking a small example only. Then I'll be coming to some misuse of this subject so that it will be easy for you to follow. Regarding this particular example, I'm taking a small example like this. Suppose that the baby feed, whether they are equally effective or not, there are say 4 brands of baby feed, they are equally effective or not. We are checking this from our data basically. So on application of the analysis of variance, we found that, okay, they are equally effective and we are taking the decision accordingly. But somebody else who is a better researcher, or he knows much more than that the earlier researcher, he tried to apply the analysis of covariance. What is the difference between analysis of variance and covariance? Covariance is you can take one or more concomitant or independent variable in the right hand side. For example, birth weight of baby, that can play a crucial role. That means the birth weight of a baby whose weight is of 2 kg in the birth weight, he can, whatever the weight gain will be applicable to him or her, the birth weight for a baby whose birth weight was say 3.5 kg will be different always. So when you are not considering this particular character, so by using the analysis of covariance technique, when we are applied the same data set, we found that there is no impact of this, there are the unequal impact. That means, see that the data set remains same. Due to change of your tools and technique, the conclusions are coming different. That means both are correct. They say person A or the researcher A who has applied the ANOVA rule, the researcher B who has applied the ANCOVA rule, and they are giving the different conclusion. Both of them are correct. But you must know to that level so that you can differentiate them whether they are correct or not. But if I just stay below certain level, I'll always say that based on their conclusion, this is not correct. So obviously, I'll appreciate the ANCOVA conclusion because ANCOVA conclusion is more realistic in nature because more complex structure and more complex variables are also used over there. Here also the same, like say in case of this COVID situation, comorbidity has one type of application of this vaccination or the outcome of the medicines. Then other the well, and those who are not any type of disease like that, they are having the different type of outcome, something like that. So directly now I am trying to explain you that means sometimes without knowing this type of tools and technique, the straight away we apply the subject, and the problem arises from the subject is that a lot of situation where we try to misuse the subject. So your first task will be to reduce the misuse of the subject. There is a statement by British politician Benjamin Disraeli. There are a lot of other statements also. I'll share my PPT with you. There you will find the applications. But there is a statement by Benjamin Disraeli, whose statement is like this: there are lies, there are damn lies, there is statistics. What does it mean? Thus, I want to cite some example to illustrate this particular statement only. See that the positive application 1 or 2 I have cited. I can say some more application also, like say people say, okay, if you just press a single rice only, you can have the very clear idea about the total rice has been boiled or not. But do you know, is it possible without knowing the regularity condition? That means if you mix up several type of rice and put it in the rice pot, your results will be different. That means if you press different type of rice, you will get different type of results. If you reduce the water to boil the rice, then also you will find the same thing. That means at the different layer of the rice, you will find different type of decisions. That means blindly don't try to apply the subject. Then your result will also be like this, the example I have cited. You have to apply this scientifically and knowing the regularity conditions and assumption of the subject so that it will be beneficial for you and the subject will give you a lot. I am trying to give you some negative application of the subject. That means you have to rescue this or you have to minimize this, then only your application of the subject or the statistical technique will lead you to a better decision knowledge. Otherwise, it is not. Now, let me take some fallacies. Through fallacy, I am trying to explain these results basically. So people say that cardiac surgeon who has the success rate is of say 80%. So on a particular morning, there are 4 open heart surgeries, 5 open heart surgeries. So 4 patients who are going to OT after successful operation, they are coming out of the OT. But the 5th one is not willing to go to OT. How can you explain this situation statistically? The second example I am trying to cite, I have asked a question just few minutes back. That means you are moving from A to B with 20 km per hour and coming back with say 10 km per hour. And what is your average speed? Here the average speed will be actually the harmonic mean. The reason is very simple. If you want, I can just try, I can give you the details of the calculation, and that value will be less than 15 actually. It will not be 15. That means those who are using this 15, you are overestimating the parameter. So that means without knowing the proper estimate, without knowing the proper application of a particular measure, you are doing the same. Then another example I can cite, in a remote area, a family has 10 family members and they have to cross a river in the summer season. The head of the family who had measured the height of the water at the different places, and he calculated the arithmetic mean of the height is say 4 feet, and he measured the height of the members. Then he found that the average height of the members comes to 5 feet. Then being the tallest and head of the family, member of the family, he ordered other members to cross the river. So crossing the river, he found that some of the family members disappeared. So if you also apply this subject in that way, that means here arithmetic mean is the proper measure, or median will be the measure, or mode will be the measure, or quartile will be the measure, or percentile will be the measure, or decile will be the measure. So lot of pros and cons are there, that you have to keep it in your mind, so that ultimately you will be able to apply this. So I'm giving you an example of the misuse of the mode. Suppose you are moving through a national highway, and you will find most of the accidents occur in the roadsides. In the left and right side, you will find that lot of accidents have taken places. So it is in your mind like that. So if I close my eye and just walk through the middle of the road, there it is the safest way of running. But to do the same, you will find the ultimate result. So these are some of the fallacy which are giving us directly the outcome of this wrong application of this subject basically. So problem is that right now what I am telling is, not only the subject is flexible, that is there is a basic difference between mathematics and statistics. That mathematics is very rigid subject, there is no flexibility, but statistics is a very flexible subject. The subject is flexible, the data is flexible, and in the midst of this flexibility, you have to take the right type of decision. But you are that means the same story. I just repeat again. 2 plus 2, the value will be 4 in case of mathematics, but in statistical decision, the 2 plus 2, there is a high chance that the value will be 4, but the value will be in between 3 and 5. So in our real life cases, any type of events occur, they are statistically correct, they are not mathematically correct, because excepting few fundamental constants, everything is changing in nature. So again, I am coming back to this particular diagram again in my book. That means this one dimension, the first dimension I have very clearly tried to explain. Just few minutes I will be taking for explaining the other dimension, that means dimension 2 and 3. For dimension 2, that means number of variables. See that if the number of variables is 1 only, in that dimension, the minimum is 1, the maximum can be anything. So if the number of variables 1, you can handle univariate case, but number of variable 1 or more, but you have uncertainty 0. So that situation you can successfully handle with the help of mathematics. If it is more than 1 variable, then you have to have some knowledge on matrix, knowledge on vector, knowledge on determinant, so that you will be able to handle these multivariate cases. That means the second dimension is the multivariate case. That means when we are having more than one variable, it can be bivariate, it can be trivariate, and so on. It's ultimately multivariate cases. So new concepts are coming. Till univariate case, we cannot think of any correlation. Whenever this two variate or the bivariate things comes, we are thinking about the new concept, which is the correlation, which is the regression. Similarly, multiple regression, partial regression, canonical correlation, partial correlation, multiple correlation, all the other techniques already quickly Soumya had stated, I have seen there. That means factor analysis, cluster analysis, conjoint analysis, discriminant analysis, path analysis, correspondence analysis, lot of activities are there. All are basically whose basic foundation is the correlation analysis. So even he has cited a nice example over there. That is, this type of correlation, there must be cause and effect between the two variables. That means sometimes we give question for the nonsense correlation, nonsense or spurious correlation. That means if the cause and effect relationship is not there, suppose the newspaper, the sales is increasing and the crime rate is increasing. So people are become criminal by reading newspapers. It's not the correct one basically. So one must be cause, other will be the effect. If you just if you give the heat, then only the water will boil and so on. So that's the one is the cause, other is the effect. That is why the causal relationship. So causal relationship must be there For ordinary correlation, there is a linear relationship, but for non-linear relation, for measuring non-linear relationship, there are some other type of correlation coefficient. It is called the index of correlation basically. So you can measure also the polynomial relation between the two variables also. So that means whenever you are in the two-dimensional space x and y, that is in one direction you are having lot of uncertainties, in other direction you are having number of variables. So being a decision maker, being a researcher, you are moving somewhere in the two-dimensional space where depending on the number of or variables you are handling and the amount of uncertainty you are having, you have to apply the tools and technique. Any tool, any statistical tool and technique we are available, they will be coming under this structure. Then quickly I am coming to the third dimension of this decision making part. Third dimension is the dynamism. That means something, the things are changing with respect to places, things are changing with respect to time. Maybe that in one city you are having one type of expenditure, in some other city having the same type of standard of living you are having different type of expenditure. So that is actually dynamics, this dynamics because of the geographical change. Similarly, with respect to time change also you can have the same, like say in our why the stock market is so difficult to measure the same, because it is continuously changing. It is very much dynamic in the sense of time basically. That's why here the time series, the forecasting technique will play, all the longitudinal techniques will play a very crucial role. Even this dynamism can come because of various reasons, like say especially in the music industry. I can cite an example. See, in our childhood days there was LP records, then small records, then cassette, then CD, then DVD, then there is nothing. So see that dynamism. What is the reason behind this? This is the technological change. There can be technological change, there can be economic change, there can be political change, there can be other type of environmental change. So the changes are continuous. So in the dynamic situation, in our childhood days, we used to measure the distance between 2 points by scale or something, some other tools. But how to measure? See that our real life cases are not so easy, because we are sending our satellites, or we are sending our, even we are planning to send human being to moon or say Mars or something like that. So everything is continuously changing, continuously dynamic in system. So how to plan this situation in that case? That means if you forget about this dynamism, then you will not be a very good decision maker in that case. So I am taking an example of the dynamism, the extreme dynamism of our livelihood or our galaxy even. See that the latest research is saying that our galaxy, the major axis, it is elliptical in nature. The major axis is of 100 light years, the minor axis is of 60 light years. So sun along with its planets or members moving around the galaxy with 25 light years distance from the center of the galaxy, and with 45 kilometers per second with this speed or velocity. So see that how can you think of the matter of dynamism? Maybe that in the before Kepler time, we used to think everything was the Earth-centric process. But now see that our research has able to extract the information in that level. So taking all together, that means as a researcher, as a decision maker, we will be having all these problems at the same time. So all the tools and techniques available to us, they are basically to help the decision making in this system. So lot of tools and technique I have stated in statistics, lot of tools and technique I have stated in mathematics, mathematical tools and technique, and lot of tools and techniques in operational research. All together, even some the different type of packages also, scientific, the practical application of these packages. That means lot of computer packages are there. But before I stop, just I want to say only one or two sentences regarding before you apply this complex situation of complex tools and techniques of statistics, my submission will be try to understand the basic concept. That means here I have tried to give you some basic knowledge of in my PPT you will find basic knowledge of this qualitative information of the data. That means in statistics, we broadly divide the data into three categories. One is called the qualitative character. That means your name is qualitative character, your income is quantitative character. But similarly, this quantitative character could be of two types again, discrete variable and continuous variable. Without having this basic knowledge, you cannot apply scientifically any statistical tools and technique. So one is attribute. That means for any qualitative type of study, attribute is very important. And for any type of variable, even the variable which you can count one by one, they are called discrete variable. The number of students present, number of accident, number of printing mistake, all these are discrete. Based on the discrete variable, you are having lot of tools and techniques. Based on the continuous variable, you can have another set of techniques. So continuous variable means uncountable infinite. So that is the one way of understanding the data, the characteristic of the data. The other way of understanding the data is that in research methodology book or any market research book, you'll find there are 4 categories of this, or 4 types of data. Actually, the statistical data is covered in the qualitative data, in qualitative technique in a different way. Nominal scale data, ordinal scale data, interval scale data, and ratio scale data. There are 4 types of data: nominal scale, ordinal scale, interval scale, ratio scale. That means even without knowing the proper categories or divisions of the statistical division of the data, if you know this, nominal means this is one type of data where you do not have any order, magnitude, and origin. That means, like say phone numbers. Phone number do not have any order. Like say if I calculate the average of the phone numbers, the standard deviation of the phone numbers, any identification number, excepting identification, no other use is there of the nominal number. Ordinal number, like say educational qualification, this has order, but this has no magnitude, no origin. So starting for this nominal type of data and ordinal type of data, all these are actually qualitative study. Nominal and ordinal, they are basically qualitative study. Even the interval type of scale, that means interval scale consisting of, there must be some order, there must be some magnitude. For example, like say taste, the stress, the type of sweetness, bitterness, etc. That you can say we are taking 5-point scale, 7-point scale, 12-point scale, etc. Whatever the type of scale you are using nowadays, Likert scale, etc. A lot of things are there. So starting from nominal, ordinal, interval, all these are basically qualitative study. The ratio scale data is per unit value we are trying to calculate. That's why this is the ratio scale data will be directly some type of quantitative information. Otherwise, this nominal, ordinal, interval, they are basically qualitative type of information. Just last example I want to give you. Say I want to measure the relation between a nominal type data and an interval or ratio type data. So the appropriate technique will be analysis of variance technique. For example, different region, different salesmen are working. So whether the salesman has any typical effect or region has any effect, that you want to find the relation, then ANOVA technique will be the appropriate. If you want to know the interrelation between the ordinal and interval or ordinal and ratio, so in that case, the Spearman correlation, like say ordinal means educational qualification and income, say for example. So in that case, Spearman correlation will be helpful. So similarly, the every statistical tool has its different application, but we don't have that much of time because this is really the C-level subject, but within 1 hour it is very difficult to explain everything. So just I have tried to make an overview of this subject. I am just expecting some question or typical type of information from your typical type of question from your side. Thank you all for this patience listening.
Thank you, sir, for showing us the right way by citing examples of wrong application of the subject. Uh, Now I request the participants to put up their questions.
The question not necessarily related to this, the area I have considered over here, but you can ask me any sort of question from statistics. Just before I Somo is my student. Actually, he's my beloved student. Still just in queue of this. I just took a question in the Somo session. I am just happy to just share the same question again. Some of the participants are asking like this, and why this 5%, 1% values were given earlier and now why it is p value. Now let me tell you very frankly, before development of these statistical packages, the tables were developed only on 5%, and if it is two-sided test, then it is 2.5%, and if it is 1%, then it's two-sided test, it is 0.05%, 0.5% actually. Now, what is the p-value? P-value is the computed value of any statistic above which the probability is calculated by the package automatically. Now, for example, in a particular situation, our calculated value comes something, and corresponding the p-value is 0.0312. This sort of thing, 0.0312. Now, if I want to take the decision the same thing at 1% level, see that at 1% level, that value lies in the acceptance region. That is why you can accept the hypothesis. For 5% level, the same value lies in the rejection region. So you can reject the hypothesis at 5%. That is, though the conclusion is different in the two different cases, but depending on the p-value decision will be more accurate in nature. Instead of depending on this 5%, 1% value, p-value means this is really the level of significance is 0.0315, whatever I have said, that is the level, not exactly the 0.05 or not exactly the 0.01, something like that. That means since computational part is very easy nowadays by using any standard statistical packages, so it will be very easy to compare the same. One part of the answer already nicely, Somo has already given the answer. That means since the things are available directly from the package, why should we go for the consulting any standard textbook or something like that? So directly by p-value, you can, p-value is nothing but the upper that value of this, that is the area above this cutoff point, that is calculated and written in the column.
Kishore sir, please ask your question.
Any other question?
Okay, ma'am. Thank you.
Excuse me.
Okay, sir. My question is,
Yes.
how to select the best research designs, and which research design is the most relevant to social science research?
Now it is a almost the entire subject, but let me tell you, even if I go for the type of research, there could be let me give you one or two examples, because I have not given detailed of anything. One is called the hypothesis testing research, one is called the causal research, one is called the descriptive research, one is called the exploratory research. Just quickly, I am just trying to explain the same. Exploratory research means nobody has done this type of research, you are doing this first time. So for exploratory research, one set of tools and techniques can be used. For descriptive research, that is some type of market research organization for a company, they are doing the same, maybe that every year. It's a descriptive type of research. That means he knows what type of variables will be used, etc. Questionnaires are designed already. Even when I worked with say, a lot of projects in the World Bank projects, they are sending the questionnaire itself. We need to do nothing. That means we cannot develop the questionnaire. They are making the composition of the research team also. That means one statistician, one psychologist, one sociologist, and so on. So depending on the problem you have to take, it's not that the general we have any answer for this. If you want to explore something, if you want to find some cause and effect, so causal techniques, tools required, and so on. So there is no unique rule for this. But as I have said, before you design any questionnaire, one must go through the scaling techniques. Scaling techniques, only the primary scales I have highlighted, but there is a lot of, it is most of the book on research methodology will get this, but this is not the part of statistics, this is part of psychology basically. So nowadays, any sort of answers you are not getting in the yes, no form, but if you like a particular product or service, if you like it up to 20%, you are giving one, ticking one in the 5-point scale. If you are liking the product or agree with the statement, say 20 to 40%, then you are ticking at 2, and so on. So I am ticking 5 means I am liking or just agreeing with the particular statement with 80 to 100%, something like that. So not necessarily you have to take always this 5 point. It can be odd point, it can be even point. Just quickly, I am giving you one example. So in most of the cases nowadays, people are taking even point, because 5 point scale means the neutral case, it is some type of loss of data. We have lot of cost for collecting data, but if somebody are saying that after this particular session, if your organizers are asking, how did you enjoy this class? If your answer is I do not know, so it has no relevance at all. Whether I have done something or I have not done anything. So it has some, that means when we are taking even point scale, you do not have any scope to be silent or neutral.
Thank you, sir. The next question asked by Dr. Titash Kumar Bandyopadhyay: how to test empirically the results obtained from mathematical analysis? How to test empirically the result obtained from mathematical analysis?
Mathematical analysis means it's probably it is not an empirical research. Probably, if it is empirical research, then already you have stated you have stated everything. If it is parametric case, that means if the distributions are available, obviously the list of tests you have mentioned. But the condition is that whether we are depending on the sample or not. If we depend on the population, you do need not to do anything, because nowadays for big data days, you don't require anything. Everything you can handle with that, because even they have no normal behavior. If the data size is very large by central limit theorem, everything will be normal in nature. So no question of arising any non-central or say non-parametric cases, because millions of data points nowadays available. So even sometimes we find say more than 30 data points, more than 100 data points, you can apply the large sample case. So large sample, even in non-parametric, in most of the cases, large sample, everything again coming to the normal. It is some type of cyclical process basically. So if the data size is large, everything you can forget, you can successfully apply the normal distribution. Normal can do say 99% of the cases. So whatever the data, whatever the type of test applicable to normal, so they can accommodate all these type of tests depending on the situation. If you are interested about the standard deviation test, you have one type of test. You are interested about the mean test, you are interested about the proportion test, one type of test. But for large sample case, mathematical analysis means I think it is large sample case. Everything, every data can be handled with the.
Yes. Dr. Bandyopadhyay, you can.
Sir, I have a question. Actually, if I make a purely mathematical paper, that is general equilibrium table, and I have done some comparative static result, and what will be the impact of this on this variable, and I get the result, and I have some economic logic behind this. But most of the papers they published for publication, they need empirical testing. and how to make empirical testing for my result. Because
if you want to just ask me the meaning of empirical testing, then in that case there is a
actually just a minute. In my paper, I have I am working with those variables, and that is wages, that is prices, that is foreign capital, that is unemployment, and I generally face the problem how to tackle the data and how to fit the data in my paper, which may give me the same or different result. মানে অ্যাকচুয়ালি যেটা আমি বলতে চাইছি, মানে সমস্ত থিওরিক্যাল পেপার যেগুলো করি সবটাকেই আমি কিন্তু এমপিরিক্যাল টেস্টিং এ আনতে পারছি, এইটাই প্রবলেম হয়
না। থিওরিটিক্যাল আমি জাস্ট একটা কথা বলি, জাস্ট লেট মি টেল ইউ ওয়ান থিং, সিন্স আউটসাইড ক্যান্ডিডেটস আর দেয়ার, so let me tell you one thing, since you are I presume that you are from economics, that's why it is
sir, he is your college in university also, sir.
I know it, that's why I'm just giving an example, sir. Demand and price, supply and price, you have developed some lot of models on the basis of this, but if you collect the data from the market, are they behaving exactly the way you have handled with the help of this model?
Right, that is a basic problem.
Let me tell you the development of statistics in that way. That means initially whether these two variables are at all related or not, even if it is even they are related, Somo খুব ভালো করে বলেছে, if they are related, even whether they are very poorly related or moderately related, or say the relation is high or very good, even within the linear restriction we are having a lot of things. So forget about other things. That means initially we are having the observations. Newton observed that the apple comes down to earth. That is why the gravitation theory developed in that way. If the apple goes in a different direction, then the theory of gravitation will be was of different type. So initially, that means any sort of model, any sort of mathematical model developed, beyond which or in the background of this type of model there is a observation, that is there is a findings based on the data. Then once they find this data, then only they have tried to develop this. The first thing is that scientists, they have tried to, the physicists, they have observed initially there are two tides daily. Then why this tide is occurring, they have tried to explore the experiment and found that okay, the moon is the reason for which this is happening like that. So initially, for any sort of scientific development, you have your observation. So that means whatever the data you have got, they are nothing but the observation. First of all, I was talking about the just overview of this observation. Even if you can plot the behavior of the data also, you can say a lot about the data. Not necessarily always you have to apply all the advanced tools and technique. Am I clear?
Yeah. Thank you.
Thank you, sir. We have another question from Mungul Liwang. How to collect data or field work during this pandemic? Is there any other method for collecting data without physical involvement?
You give the answer for this. I'm rendering this to you, so Somo will be able to answer the same.
So, madam, I already said in my presentation that you can go for Google Docs, and Google Form is available. You can send to email whoever you want to. If you have the email ID, you can post it there through the Google Form. You can collect your information without the physical involvement. So that's the answer of your question. Probably Sarita.
Yes. Next question.
Sarita ma'am is asking something. Ma'am, can you?
Whenever we are taking into the nonlinear correlation, how to measure the nonlinear correlations?
There is a correlation known as the index of correlation. Index of correlation. Search this. Index of correlation has some suffix.
So is it the method, sir, index method?
No, not index number. Index, the name is itself index of correlation. If index is 1, then that is the linear relation, that is measuring the linear relation. If index 2, that is measuring the quadratic relation. If index 20, that is measuring 20-degree polynomial relation. Now here typically, I don't know your basic subject, but why I'm talking about the nonlinear means polynomial. There could be logarithmic, there could be exponential, there could be sine, cos, etc. But in most of the cases, one of the chapter, Somo has already also studied this, interpolation, extrapolation. So everything we can estimate through the polynomial. Polynomial is much closer to any type of mathematical curve, even which is unknown to us. That's why we are trying to estimate this interrelationship of the polynomial curve only, not all types of curves. That is, nonlinear could be say billion type of different type of relation. Linear is only one, but we are interested only nonlinear means polynomial relation, because nonlinear curve goes in zigzag way. The error is less and less for the nonlinear one. That means it is approximated value for the original mathematical curve. So Newton's forward, Newton backward, Lagrange's, etc. All these are actually this based on this polynomial we have estimated this.
Thank you. Sir, one more question, sir. So in the Poisson distributions, the more errors are there. So which distribution we are taking, sir? Either directly we can go to the normal distribution, sir?
No. One thing is that Poisson and binomial, the mostly use discrete distribution. First of all, you must know the difference between discrete and continuous. Discrete means you can count them one by one. They can be finite, they can be countably infinite. But continuous means uncountable infinite. For both binomial and Poisson, if the sample size is very large, every distribution will go to the normal distribution, central limit theorem. That is known as the central limit theorem. For more specifically, say for binomial goes to normal, it is specifically due to De Morbihan and Laplace. So it is called De Morbihan's Laplace theorem and so on. But in general, that is called the central limit theorem. That means if the sample size is large, then everything will go to the normal distribution. Even the discrete data can be handled with the help of the, like say proportion test we have done, all the binomial type of data. But we are handling the analysis with the help of the normal distribution. Because p-test you have handled, you can remember, any proportion test, whether it is single group or it is multiple group or two groups. For multiple group, it is the test of homogeneity, which comes under the frequency chi-square test. But for two groups, it is normal again, because all the tests we do all these tests under the large sample situation. If it is small sample, then exact test is there. But for that, the things are not very easy for general students actually, because in that case, based on the distribution, you have to calculate the p-value, the probabilities. Then only you can compare the sample. Based on exact distribution, based on Poisson, based on binomial, we can also perform the test also.
Yes, so generally, as in these large means, we can take either greater than 30.
Usually, it is given more than 30, but in every cases, I can tell you the background. Actually, the variance part is calculated by or approximated by some polynomial equation. Suppose polynomial is the 1 plus 1 by n. In other polynomial, it is 1 plus 1 by n square. So 1 by n square is easily converging to 0 than 1 by n. For example, 1 by 10 is going to 0 and 1 by 10 square is going to 0. The rate is much faster for n square. So depending on this type of polynomial by which it is approximated, it depends. But broadly speaking, people say like say more than 30. There is no standard rule like that. But 100 or more, you can easily
standard books they are taking for n greater than 30, sir.
That's why I have tried to explain this more specifically. That means it is the variance part or the standard error part is. Standard error has also a different interpretation. Standard error is nothing but the gap between the parameter and statistic. It is the average distance between the parameter and statistic. So if the standard error is more, then obviously the error is more. If the standard error is less, that means ultimately standard error is approximated by a polynomial. So if the polynomial is of 1 by n square order, If the polynomial is a 1 by n cube order, then maybe that say 10 will be the large sample. If the polynomial is 1 by n order, then say 150 or 100 will be the large sample. Am I clear now?
Thank you, sir, for your nice presentation. I have somebody is there, Rakesh Chaudhary by this ID. He or she has some question. Can
Yes,
she
yes.
ask? She's asking me in my session.
Okay, okay. You just no problem. You can ask it.
No,
If it is
I will
possible for
refer to
me.
you. I will refer to you. Rakesh Chaudhary, by this name, someone is there. If you are present, please ask your question.
Or you can just read out the question. I'll try.
Okay, no questions. No questions. There is no questions. Okay. So, sir, we have no question. If anyone have any question, please ask, or we'll formally end this session for today.
Even at last, I can tell you my email ID as well as my only mobile number I have shared with in the PPT. So for any sort of query, directly you can send me message. Directly you can talk to me for any type of query, because it's a 1 hour class. Even I have taken some more time. Still, that is not enough for us. But thank you so much. You have helped me a lot also.
Thank you, sir. It's my privilege. You always helped us, so this is now our chance to help you out in some way or other.
You also presented your part very nicely. I have seen.
Thank you,
your
sir.
last
We
part.
don't know anything based compared to you, so we are trying. We learn statistics from you, and definitely we are going for this. So now I request Munun ma'am to formally end this session.
Thank you very much, sir. And as Oswald, it was a pleasure to hear you again. I am attending this session after a long time. I've enjoyed it thoroughly. I hope the participants have also been enriched, and it has been very kind of you. Like, nobody shared their personal phone number with the students and participants, but you are so kind that you have shared your number, and I feel that these our participants are very, very lucky to get guidance from you. Thank you, sir. Sorry, you have put yourself on mute, I think.
Sir, apnar microphone mute.
Sorry. So, but this is our task basically, because we'll survive through our students and these participants. That's why it is our duty to share all this with the participants and our
Thank you,
students also.
sir. Thank you, sir. With that, we end this session formally. And we will ensure that the recording of the PPTs are sent to the participants.
Okay. Thank
Thank
you
you,
again.
and good night.
I have
And
enjoyed a
please,
lot also.
Thank you, sir.
Yes, sir. Please stay safe, sir.
You are welcome.
Thank
You
you,
are
sir.
also.
Thank you, sir.
My wish will be also the same to all of you. Thank you.
Thank you. We end it formally.
Thank you.
You can leave now. All requesting all the participants to leave. We will send the recordings definitely, and with due permission from each resource persons, we are definitely going to share the presentation if they use their PPTs. For me, I can definitely share. I will share my PPT with you. It will be sent in your respective email IDs with due time. So thank you for joining. And recording is also available with you. Due to some technical issues, we are not able to send. So definitely you are going to get it. Thank you for attending.
Thank you, sir.